Hi everyone, today I will talk about the characteristics of solid figures. First thing about the types of solid figures, first thing for the polyhedrons. So the polyhedrons are the three-dimensional figure whose surfaces are polygons. So each polygon is face of the polyhedron, and an edge is a segment that is formed by the intersection of two faces, and a vertex is a point that is formed by three or more edges that intersect. So for example, there is a figure and to have the vertex and the edge in the face of this figure, we will have to find it by the intersection of the points or the faces or the surfaces. So for example, in here, this is the vertex and this is the edges and this is the face. And as I said, to make sure this is the vertices. Now to talk about the types of the polygons. So the polyhedrons. The first one is the prism. So the prism is a polyhedron with exactly two congruent, so parallel bases and a congruent lateral faces is called a prism. So they are named by the shape of their bases. So for example, there is a prism in here. And this prism is called a rectangular prism because the base of it might be rectangle, because if we confirm it, and this is the base of the prism, and this is called a rectangular prism. And if the bottom of it is triangle, it is called a triangular prism. So this might be called a triangular prism. So it depends on which shape the bottom is, and if we know the bottom, then we can know what prism it is. And now to talk about how to have the surface area of these kinds of things, then the surface area is decided by, so the surface area is decided by 2 times the base plus lateral faces, and the lateral faces is decided by the height times the perimeter of the base. Because all the places are congruent, we only have to know the number of the bases in order to know the surface area. And also the volume might be the area of the base times the height. So the volume is height times the area of the base. So this is the volume. Now that we know about the prisms, now let's go on to the next type of polyhedron. So the next type of polyhedron is the pyramid. The pyramid is a polyhedron which has the base of any polygon and lateral faces of triangles that meet at a common vertex is named by a space. So it is also named by a space. So for example, there is these kinds of pyramids. And because this is the base is the triangle, we can confirm that it is a triangular pyramid. And if the base is rectangle, it might be a rectangular pyramid. Then now, to know about the surface area is the area of the base plus the perimeter. So how much the size of the number of the size of the base times the equilateral face, which is a triangle. Why it is equilateral is because all the sides have the same length. Now, to have the volume is 1/3 times the base times the area of the base. We only have to remember these kinds of informations about the surface area and the volume, and that it has all the unique names by space and that it is a pyramid. Now the next one. So the next one is the frustum of the pyramid. Frustum of the pyramid is a bit like taking off the top part of the pyramid. So for example, to draw something, we know that this is a pyramid. But if we take off this part, then the left part is here. So here is the frustum of the pyramid. So it is, if we cut the top of the pyramid parallel to its base, the one which doesn't have a vertex is a truncated pyramid or a frustum of the pyramid. So the truncated, there is like a truncated rectangular pyramid or the truncated triangular pyramid, but also by the shape of its base. If it is rectangular, then it's a rectangular pyramid. And if it's triangle, then it's triangular pyramid. And how to have the surface area is that the surface area is the area of the two different bases plus the lateral faces. The lateral faces have all the same kinds of surface areas. And now, what about the volume? The volume is the bigger pyramid's volume minus the smaller pyramid's volume. Now, we will look at the regular polyhedrons. The regular polyhedrons, there are a lot of types of regular polyhedrons. To talk about, firstly, there's the tetrahedron. This is the tetrahedron, and it has the equilateral triangles on it. So it has the same size. And also it has triangle on the base. And the number of each vertex is, firstly, the vertex that is in the face, one vertex has 3 faces that are with them. 1, 2, 3. And now to figure out the number of the faces, there are 4 faces. As we see, 1, 2, 3, 4. And then the number of the vertices are 1, 2, 3, 4, and the number of the edges are 1, 2, 3, 4, 5, 6, so it's 6. Now, next one, so the hexahedron. So the hexahedron is sort of like a cube, but a regular cube. So the regular cube might be like this. So this kind of regular cube has a lot of characteristics, which is that it has 6 faces and 10 vertices, 8 vertices, and 12 edges. And it is the shape of the faces are all square, as we can see. The next polyhedron is the octahedron. The octahedron has 8 faces, and also it has 6 vertices and 12 edges, and one vertices has 8 faces that are next to it, and also the shape of the faces is an equilateral triangle. Now we'll learn about the dodecagon. The dodecagon has 12 faces, which we can't draw right now because of time, and there are 12 faces and 20 vertices and 30 edges. And also the shape of this face is the regular pentagon. And now, lastly, the icosahedron. So the icosahedron has a shape of the face which is an equilateral triangle, and also it has 5 faces that are meeting at one point, and 20 faces and 12 vertices and 30 edges. So these are the 5 polyhedrons, which are the types of the polyhedrons. So these are the regular polyhedrons, which are not just polyhedrons. So that's all the faces that are the same, and all the vertices that are the same, and all the edges that are the same. And now you learn about the solid of rotation, which is like solid of revolution. So to show you, this is a solid of revolution. So these kinds of solid of revolution is rotated along an axis of rotation, and it becomes a 3-dimensional figure, a solid of rotation. For example, like there's a cone, and there's a cylinder, and there's a sphere, as we see. What are the characteristics of these kinds of rotation, solid of rotation? So the characteristics is that they have one axis and they are spun by it, and also we can see a lot of characteristics that if we cut this, then we will see a kind of a circle, and we can't have another things except for a circle. So to see one more time, we can see this one more time, and also if we see a truncated rotation, solid of rotation, which is not on here. But if we cut this cone, then we will earn a truncated cone. So now you see the characteristics of these kinds of solid of rotation. So firstly, the cutted face is always a circle. Secondly, if we cut these kinds of solid of rotation, then what will we earn? Yes, we will earn a congruent polygon, which will be an equilateral triangle or a rectangle or a sphere. From the sphere, we will earn a circle, and we will sometimes earn a kind of quadrilateral, which has 4 sides because of the truncated cone. And sometimes we will know that it is symmetrical to the axis. And lastly, we can know that it cannot be somewhat irregular. So it cannot be sometimes this. However, it has to be symmetrical to the axis that rotates it, as we saw in this kind of video, because it's something that rotates. Now we are almost end. After we learned about some things about surface area. So I have said about all the surface area, however, I didn't say about the spheres. So the sphere surface area is a sphere. The surface area, if we have some kinds of light in here, then there might be a shadow, which has an area of pi r cubed. So there will be 4 kinds of these shadows, and eventually it will be 4 pi r cubed. And we can learn this by also putting the yarn on it and to put it in a circle, like these kinds of circles. And also, the volume of it is 4/3 pi r cubed. So we should know this in order to solve some kinds of problems.